Hello everyone, welcome to Sarthi Education. So let me first tell you what is this all about. So Sarthi Education, our aim is to be with our students to guide, to motivate or mentor as well as accompany them in their endeavors and educational journey. So Sarthi Education, this whole concept is we are a network of passionate academicians from various fields. So we have more than 8 years of experience in this education field. And from all these years of experience, we have come to a question why education is so costly in our country. When the education is simply a fundamental right, then why do we have to pay so much for this? So, in our endeavors to solve this educational puzzle, we have brought this thing to you so that you can learn in an amazing way and that too at such a low price. So, we have different amazing courses for you all which you can easily access by visiting our site www.sarthieducation.com. We will be covering class 10 CBSE science and maths topics and strictly restricting ourselves to focus on CBSE class 10 board exams. We know that in the first week of March, all of you will be having your CBSE class 10 board exams. So we will be taking up revision classes for this whole month in the month of February, and we'll be covering all the science and maths topics, physics, chemistry, biology, and maths topics. So this first session is chemistry session, and we will be discussing the previous year CBSE questions for the first chapter, which is chemical reactions and equations. So let's start with this first chapter. So how we'll do this? We have these questions with us, and one by one, I will be telling you the answers, how to answer the questions in the board exam, and how will you write, and simply we will learn the concepts also. So first, the first question is write a balanced chemical reaction between sodium carbonate and hydrochloric acid, which is HCl, indicating the physical state of the reactants and products. Now, first thing that you learned in this chapter is that apart from writing the chemical equation and balancing it, we have to write the physical states also of each reactant and the products which have been formed. So let's start with this. So we have this sodium carbonate, which is Na2CO3 plus hydrochloric acid, which is HCl. First, we will write just the formula, chemical formula of sodium carbonate and HCl. Later on, we will balance the equation. These two gives me, now this is my base, sodium carbonate, and this is my acid. So actually it will be a neutralization reaction. So we get NaCl plus H2CO3. Now this H2CO3 further disintegrates into H2O plus CO2. So ultimately products we get are NaCl, H2O and CO2. Now let's balance this equation. We have two atoms of sodium. First we start with the metal. Balancing starts with the balancing of atoms which are metal atoms. So we have two metal atoms of sodium. Here we have one. So we will put two here. Carbon atom we have one here and we have one here. So it is balanced. In case of hydrogen we have two here. And here we have only one hydrogen. So we will put two here, and chlorine atoms are also two here and two here. So this equation is balanced. Now lastly we check oxygen and hydrogen atoms. So oxygen atoms on the left hand side is 3 and on the right hand side 1 plus 2 3. So oxygen is also balanced. So first we will write the chemical equation, then we will balance the equation, and lastly we'll mention the physical state of the reactants and products. So Na2CO3, we all know it is a solid, white solid. HCl, we have a solution of HCl, so it will be in aqueous state. Now NaCl, which will be formed, it will again be in aqueous state because it will be in the solution only. And H2O, will be formed, it will be liquid, and CO2 gas will be evolved. These are the states that we have to mention. So we have to chalk out the question in 3 steps. First, we will write the chemical equation, and then we will balance that equation, and lastly, we will mention the physical states. Now, we will move on to second question. Balance the following chemical reaction: lead nitrate decomposing to form lead oxide plus nitrogen dioxide plus oxygen gas. Now, this is an example of decomposition reaction. Decomposition reaction. Now we have been asked to balance this chemical equation. First, we will write this here. Lead nitrate on heating gives me lead oxide, which is solid, plus NO2 plus oxygen gas. So we know that nitrogen are 2 atoms, but here we have only 1 atom of nitrogen here. Oxygen are 6, but here we have 2 plus 2 4 plus 1 5, and lead is 1 and lead is 1. So how do we go about this? Let's say here nitrogen is 2. We'll put it 2. But now oxygen will be 4, 5, 6 and 7. But here oxygen are only 6. So what do we do? So we will try to put 2 here. Lead will be 2 atoms on the left hand side. Here also we will have to put 2 here. Nitrogen are 2 into 2 4. We will change the number 4. And now we'll balance the oxygen. 4 to the 8 plus 2 10 plus 2 12. We have 12 oxygen right hand side. Here we have 2 to 4 into 3, 12 oxygen is left hand. So this is the balanced equation. So the coefficients will be 2, 2, 4 and 1. We need not write this one, but just for writing purpose, we can write it here like there is only one molecule of protein. Now let's move on to third question. We have to balance this. Iron is reacting with water to form Fe3O4 plus H2. Now this reaction you must have seen or must have learned in the third chapter, which is the metals and non-metals. So we'll try to balance this reaction. We'll write Fe plus H2O giving me Fe3O4 plus H2 gas. Now we will first balance the metal atom. Here on the left hand side we have 1 atom of iron, but on the right hand side we have 3 atoms of iron. So simply we will put 3 here. Now iron is balanced. What about oxygen and hydrogen? Hydrogen is 2. Hydrogen is 2. But oxygen is 1 here on the left hand side, but 4 here on the right hand side. So to balance oxygen, we'll put 4 here. Now hydrogen will be 8. We'll have to put 4 here also. Now it gets balanced. So first step in balancing the chemical equation is we balance the metal atom. Then we move on to non-metal atom, and in the last we balance the oxygen and hydrogen. Now we'll move on to fourth question. Now FeSO4, which is white solid, it is getting decomposed into ferric oxide, sulfur dioxide and sulfur trioxide. These two are gases, and Fe2O3 is solid. This is also solid. So this is a classic example of decomposition reaction. Decomposition reaction. So how we'll do it? Simply we will write it here. FeSO4 giving me upon heating Fe2O3 plus SO2 plus SO3. Here we will see we will first balance the number of metal atoms. Here we have 2 iron atoms, but here we have only 1. We'll put 2. Now we'll go to non-metal atom. This sulfur. Sulfur on the left hand side we have 2 atoms, and on the right hand side 1 and 1. 2. Sulfur is also balanced. What about oxygen? Left hand side we have 8 atoms of oxygen, and on the right hand side we have 3 plus 2, 6, 5 plus 3. So oxygen is also balanced. So we have a balanced chemical ferrous sulfate. So let's move on to next question. If you have any doubt, then you can ask in the chat also. And if you want me to go slow, then also you can write. So now the next question is types of chemical reactions. Now this whole chapter is only about the types of chemical reactions. There are different types of chemical reactions, and we have to know those types plus two examples of every type of chemical reaction. So let's see this. How many types of chemical reactions we have studied in this chapter? So we have studied around 5 types of chemical reactions. First is we have combination reaction. Combination reaction. Now, what is a combination reaction? When two or more substances, when two or more substances combine to form a single substance, then it is a combination reaction. Okay. So, what are the examples of a combination reaction? We can have the combustion of carbon as one of the example. So, what will be the example is like let's say we have carbon which is in solid state plus oxygen gas to form carbon dioxide gas. Just remember this that whenever you are quoting an example, then you have to mention the physical states of the reactant. It is expected from you, even if it is not mentioned, that you have to mention these, but you have to mention these. Now, combination reaction is there. Another combination reaction example can be we have NH3 ammonia gas reacting with HCl, which is also in gaseous state, to form ammonium chloride. To form ammonium chloride. Now, this is a solid. We have a solid here. This is ammonium chloride. Now, other examples can be more examples can be let's say ki we are forming ammonia by the combination of nitrogen and hydrogen. So that can also be an example of combination reaction. So let's move on to second type. We have decomposition reactions. Now, what is a decomposition reaction? Opposite of combination reaction. When a single substance breaks to form two or more substances, then it is a decomposition reaction. And we have just saw many examples of decomposition reaction. For example, decomposition of ferrous sulfate crystals. So, ferrous sulfate crystals upon decomposition form ferric oxide plus sulfur dioxide gas plus sulfur trioxide gas, SO3 gas. And now this Fe2O3 is solid and FeSO4, of course, this is solid. So these are my ferrous sulfate crystals. Ferrous sulfate crystals. Now, other examples can be decomposition of lead nitrate to form nitrogen dioxide and oxygen gas that we studied above here. This is also a decomposition reaction. The decomposition of lead nitrate to form lead oxide, nitrogen dioxide, and oxygen gas. Now, the third type will be displacement reaction. Third type is displacement reaction. Displacement reaction. Now, in this, what happens is that a metal atom displaces another metal atom or another atom from its salt. For example, we have zinc plus copper sulfate. Now zinc is in solid state and copper sulfate we have an aqueous solution of copper which is blue in color. So what happens is that zinc displaces copper sulfate from a salt to form zinc sulfate solution, which is an aqueous solution, plus copper is formed in solid state. So this is my displacement reaction. Fourth type is double displacement reaction. Fourth is double displacement reaction. Now, what can be the example of double displacement reaction? Let's say we have barium chloride, BaCl2 plus H2SO4 sulfuric acid, and we get BaSO4, which is a white PPT, plus 2HCl, which is in aqueous form. So when we react barium chloride with H2SO4, we get barium sulfate plus 2HCl. It's like swapping the partners. Barium has swapped its partner, which is chlorine, with hydrogen. So barium has got along with sulfate, and hydrogen has gotten along with chlorine. So we get barium sulfate and hydrogen chloride. Last type is redox reaction, which we will study later. Redox reaction. Redox reaction. And what is a redox reaction? It is the reaction in which oxidation and reduction both occur simultaneously. That is a reaction in which oxidation is happening and reduction is happening, and these two are happening at the same time. Then that reaction is redox reaction. We can see it from here. Redox, red and ox. So red means reduction and ox means oxidation. So red is reduction and ox is oxidation. So this is a reaction in which both oxidation and reduction are taking place at the same time. So what can be the example of oxidation reduction? Let's say we have carbon plus oxygen giving me carbon dioxide gas. Okay, so here oxidation is addition of oxygen. So carbon is getting oxidized to carbon dioxide and oxygen is getting reduced to carbon dioxide. So who is getting oxidized? Carbon. And who is getting reduced? Oxygen. So let's move on to next question. In the electrolysis of water, why is the value of gas collected over one electrode double than that of gas collected over the other electrode? So let's see. Hmm. So in the electrolysis of water, we have what happens is we have water H2O getting electrolyzed. This is in liquid state. This is getting electrolyzed. We are performing electrolysis over water. We get hydrogen gas plus oxygen gas. So let's balance this equation. We get 2H2O, 2H2 plus O2 gas. So we can clearly see that hydrogen gas which has been collected is double than that of the oxygen gas which has been collected on the other electron. Now we have to remember that the hydrogen is collected at cathode. This is collected at cathode where reduction takes place, and this is collected at anode where oxidation is taking place. So hydrogen gas is which has been collected over cathode is double than that of the oxygen gas which has been collected over anode. So let's move on to next question. What change of in color is observed when white silver chloride is left exposed to sunlight? So what happens when white silver chloride, which is ECl, it is left exposed to sunlight. So we have the following reaction. AgCl, when we put it in sunlight, it forms silver, which is solid, plus Cl2, which is gaseous. So let's balance this equation. So we have two chlorine atoms here. So this silver chloride, which is white in color, what change in color is observed when white silver chloride is left exposed to sunlight? This white colored silver chloride turns gray due to the formation of silver. This white silver chloride turns gray due to the formation of silver. Now this type of reaction is known as, of course this is a decomposition reaction because a single substance breaking to form two simpler substances. So this is a decomposition reaction. But more specifically, this is a photodecomposition reaction. This is a photodecomposition reaction. So this is a decomposition reaction which is taking place in sunlight, and then that reaction is known as photodecomposition reaction. So now move on to next question. What happens chemically when quicklime is added to water? Now what is quicklime? Quicklime is calcium oxide. Quicklime is calcium oxide. So when calcium oxide, it reacts with water, which is solid in state. When we put it in water, which is liquid, then calcium hydroxide is formed. Calcium hydroxide is formed in an aqueous solution. Now we have to mention two things. This calcium oxide is known as quicklime. We know. Calcium hydroxide is known as slate lime. That we have to know that calcium hydroxide is slate lime. So when quicklime is added to water, slate lime is formed. Another thing that we have to know is that this is an exothermic process. This is an exothermic reaction. So here we have an exothermic reaction, and the example is addition of quicklime to water to form slate lime. So this is an exothermic reaction. As a result, along with slate lime, we get large amount of heat energy. So along with slate lime, we get large amount of heat energy. So this is an exothermic reaction. So two things that you have to remember is that quicklime upon adding to water forms slate lime, and slate lime is calcium hydroxide, and this is an exothermic reaction. So let's move on to next set of questions. So here we have, what happens when an aqueous solution of sodium sulfate. Now what is sodium sulfate? Sodium sulfate is Na2. It reacts with an aqueous solution of barium chloride, BaCl2. Now what happens when an aqueous solution of Na2 and BaCl2 reacts with each other? So let's start with the chemical reaction. Na2SO4 plus BaCl2. First we will write the reactant, then we will think over the products. Now this can be a double displacement reaction. Simply sodium will swap its partner with barium. So we will get sodium chloride plus barium sulfate. First we will complete the chemical equation. Then we will think about balancing this equation. So first start with the metal. Sodium we have 2 here on the left hand side, so we'll put 2. Barium is 1 and barium is 1. Sulfate ion, 1. Chloride ions are 2 two chloride ions on the right hand side. So this is the balanced chemical equation. Now we'll have to state the physical conditions of the reactor. Now this sodium sulfate will be an aqueous solution. We have already been given this is an aqueous solution of sodium sulfate which reacts with an aqueous solution of sodium chloride. So this is also an aqueous. Of course, this NaCl found will be in aqueous solution only, and we have to learn this that barium sulfate is always formed PPT. It is insoluble in water, so it forms as a solid. So this is a white PPT precipitate. Now name the type of the reaction which is this type of reaction. Of course, this is a double displacement reaction. This is a double displacement reaction. And one amazing thing with this is that when in a double displacement reaction, one of the products formed is in the form of a precipitate, then reaction is known as precipitation reaction. Precipitation reaction. So precipitation reaction is a double displacement reaction in which one or more than one products forms a precipitate. So the type of reaction you can write either double displacement reaction or you can write it is a precipitation reaction. So now move on to what is a redox reaction. So we have earlier studied that what is a redox reaction. Redox reaction is the one in which both oxidation and reduction take place simultaneously. Now this is my redox reaction. So oxidation is also happening, reduction is also happening. So what is meant by oxidation? Oxidation we can mean any these three of things. This is gain of oxygen or loss of hydrogen or we can have loss of electrons. So if any one of these three things is happening, then we can say it is an oxidation. And what about reduction? Reduction in this again we have three things. If in oxidation there is a gain of oxygen, then in reduction it will be opposite of that, loss of oxygen. In this, gain of hydrogen or we can have gain of electrons. So whether it is a redox reaction or not, we have to just check whether oxidation and reduction is taking place or not. If both are taking place, then it is a redox reaction. Otherwise, if only one of these things is happening, if simply oxidation is happening, then it will be an oxidation reaction or a reduction reaction. If both the reactions are happening at the same time, then it is a redox reaction. Now, the second part of the question is when a magnesium ribbon burns in air with a dazzling flame and forms a white ash, is magnesium oxidized or reduced? So, first we'll have to write the chemical equation. Magnesium burning in air, so we'll provide some heat and it forms magnesium oxide, which is white in color. So, let's balance this. We have 2 and 2. This is a balance equation. Now, we can see here that magnesium is getting attached to oxygen to form magnesium oxide. That means magnesium is gaining oxygen to form magnesium oxide. It simply means magnesium is getting oxidized. So here magnesium is getting oxidized. So oxidation of magnesium is taking place. So magnesium is getting oxidized. Similarly, if magnesium is getting oxidized, then oxygen must be getting reduced. So we will write O2, not oxygen O, but the whole O2 compound is getting reduced to form magnesium oxide is getting reduced. So this is the concept of redox reaction. You have to know but just these things, that what is a redox reaction, what is oxidation reduction, and in a reaction how do we identify whether which one is getting oxidized and which one is getting reduced. Now let's move on to next question. What is the color of ferrous sulfate crystals and how does this color change after heating? Now let's see what is ferrous sulfate crystal. Ferrous sulfate is a hygroscopic substance. So it absorbs water and this 7H2O, these water molecules are water of crystallization or water of crystallization. So these are the water molecules of crystallization. So ferrous sulfate has absorbed the water molecules from air or from the solution and has formed ferrous sulfate, these crystals which are light green in color. They're light green in color. So what happens is that when we heat those crystals, upon heating, they lose this water of crystallization to form anhydrous ferrous sulfate crystal, which is solid and white. So we have anhydrous ferrous sulfate, anhydrous, that is, it doesn't contain water anymore, and these are the hydrated ferrous sulfate crystals. So these are anhydrous ferrous sulfate crystals which are white. Plus 7 water molecules are lost. Now the second part of the question says name the products formed on strongly heating ferrous sulfate crystals. Now we know that upon strongly heating ferrous sulfate we get ferric oxide which is solid plus SO2 gas is evolved plus one more gas is evolved which is sulfur trioxide. So ferrous sulfate, when we heat it slightly, then it loses water molecules. And after we have got this anhydrous form, if we continue heating this, then ultimately we get ferric oxide. So this is white solid, but ferric oxide is reddish brown. Ferric oxide is reddish brown. So we had been asked how does this color change after heating of ferrous sulfate crystals? So upon heating ferrous sulfate crystals which are light green in color, we obtain anhydrous ferrous sulfate which is white in color. So there is a change in color from light green to white. And after strongly heating this white FeSO4, we obtain a reddish brown ferric oxide and SO2 and SO3 gases are evolved. Now let's move on to next question. What is observed when a solution of potassium iodide is added to a solution of lead nitrate taken in a test tube? And now what type of reaction is this? So let's start with potassium iodide is Ki. We have a solution of potassium iodide and it has been added to lead nitrate. We have lead nitrate PNO3 twice. Now this is also an aqueous solution, so we'll write the physical state as. What will happen is that again it will be a double displacement reaction. Potassium will swap its partner with lead. We'll get potassium nitrate KNO3 which will be in aqueous state of course plus lead iodide which is solid and it will form a yellow PPT. This is lead iodide, so it will form a yellow PPT. So if we balance these equations, we'll get potassium is 1, potassium is lead is 1, lead is 1. Now moving on to non-metal ions atoms, this iodine is 1 here, but iodine is 2 here. So 2 here and 2 here, balance the potassium atoms, and NO3 nitrate ion is balanced 2 here and 2. This is the balanced chemical equation of reaction between potassium iodide and lead nitrate. Now, what type of reaction is this? We all know this is double displacement reaction, or we can write it as a precipitation reaction because a yellow PPT of lead iodide is being formed in this reaction. Now, last question is, what is an oxidation reaction? We've all we have studied this. What is an oxidation reaction? So, oxidation reaction involves one of the following three things: gain of oxygen, or loss of hydrogen, or loss of electrons. So, oxidation reaction is the one in which there is a gain of oxygen, or there is a loss of hydrogen, or there is a loss of electrons. So, one of these three things, if it is happening in a reaction, then it is an oxidation reaction. Now, identify in the following reaction the substance getting oxidized and the substance getting reduced. Now, we have ZNO plus C gives me zinc plus carbon monoxide. So, we are reacting zinc oxide with carbon form zinc plus carbon monoxide. So here we can see that zinc oxide is getting rid of oxygen. So there is a loss of oxygen. So definitely this is reduction. There is reduction of zinc oxide because it is getting rid of oxygen. On the other hand, carbon is getting attached with oxygen to form carbon monoxide. So this is definitely oxidation reaction. So we know that reduction is taking place here. Zinc oxide is getting reduced to form zinc. So the substance which is getting reduced is zinc oxide. It is getting reduced. And oxidation, for oxidation, carbon is getting oxidized to form carbon monoxide. So carbon is getting oxidized. One thing that you have to remember is that in this case, when zinc oxide is getting reduced to zinc, you will not say that zinc is getting oxidized from zinc oxide to zinc, but the whole compound is getting reduced. Not simply zinc, but the whole compound is getting reduced. So in the answer, you will write the whole compound zinc oxide, not simply zinc. That will be wrong answer because the whole compound is getting reduced to form zinc. And similarly, carbon is getting oxidized to form carbon monoxide. So this was all about this questions, and I hope that these questions are enough for the first chapter. We are just practicing for the CBSE class 10 board exam. So what happens is that from this first chapter, apart from these questions, I don't think that any question is left or any topic is left. So you can prepare only these questions, and we'll be providing you other questions also with their answers, and you can practice those questions also. And apart from all this, all these live sessions, we have for you doubt support sessions. In this, there you can mail us your doubts or you can message us your doubts, and we will reply you or we will just answer you. If the answer is not possible on the mail or on the message, then we can have a doubt session, and this all of this will be conducting in this February month only, because in the first week you have your board exam. So in the February month, we'll be conducting all the live sessions for the science and math sessions, and in between we can have doubt sessions or if you want to just clear it out over phone or message or over email, then you can do so. And there are other courses also which you can just see by visiting our site www.sarthi.com. Now this was the first session. So next for the next session, you can use this coupon early bird, and we have all sorts of packages on our website, and you can purchase the packages at very low cost. And you will be covering all the maths and science CBSE questions over there. And apart from those questions that we'll be covering in the live sessions, we will be providing you some sample questions, and this video will also be mailed to you. And these notes that I have written and all the questions that I have solved, this whole thing will be mailed to you. So this first session was a free session, and next session will also be a free session. From next session onwards, only those people who have purchased that course will be able to see this session and will be able to access that material. And since you people have joined the first session, so we are providing you with this coupon early bird, and just apply that coupon when you are purchasing the course, and you'll get 50% discount. After the first session, whoever will be joining and who don't have this coupon, they will have to pay the full price. But since you people joined the first session, you people have this coupon early bird. Just type in the early bird over there and you will avail this coupon, so you will get 50% discount. So regarding the next session, we will having it tomorrow same time. And apart from that, if any kind of information that you need, that you can visit our site, or you can message us, or you can email us. And in between, from today to tomorrow, we'll message you up about the timings and the link to this video. If you are not able to watch this video, then we will mail it to you, and the sample paper also, and we'll provide your memory map also, the for the whole chapter, that you can just study before the exam, and the whole chapter will be covered. So I think that's all. If you have any doubts, then you can mail us. So let's stop this feed. So best of luck for your exams and for your preparation. Bye.